Today we're moving to Chapter 6. We're going to be talking about 6.1, Composite Functions, which begins on page 415. I would encourage you to read this little introductory paragraphs. I think that might help you understand what a composite function is. The notation for composite function looks like this. F with this little tiny O composed with G. It's called F composed with G, and that means you take F of G of X. So you start with G of X, and then you substitute that into F. We talked, those of you that were with me previously will remember that we talked about this near the end of the term, last term. But we're going over everything new, so it's okay if you don't remember it. This is a type of diagram that I like to use. I think it gives us a picture of what's happening. You start with some number x, and you substitute it into the function for g, whatever that might be, whether it's multiply by 2 and add 3, or multiply by 4 and add 7, or whatever it might be. You substitute x into that function, and that gives you an answer. Then you take that answer and substitute it into into f, into function f, and whatever you get, then that's your final answer, and that is called a composite function, when you take the output of one function and input it into another function. And when we find the rule for the composite, which will be the second group of problems, we're finding a different rule, a brand new rule, that if I start with this x, I end up with this answer. So the composite rule is something that can take the place of doing two of them individually. Alright, the first group of problems we're looking at on page 420 give us specific values, so we can just use that input-output scenario. I'm starting with number 13, and it tells us that f of x is 2x and g of x is 3x squared plus 1. And it asks us to find f of g of 4. So I wrote it like this, f of g of 4. I should have another parenthesis right there. So what I'm going to do is come over here and find g of 4, which means I substitute 4 for the x in the g function. So I substituted in 4, and I got 49 for the answer. Now I bring that back over here and find f of 49. Well, 49 says multiply by 2. So I just take 2, multiply it by the 49, and that's my final answer. Alright, part B asks us to do g of f. That means you start with f and then do g, and the number they give us is 2. So we're going to do g of 2. Well, we're using these same rules, and the rule for f said multiply something by 2. So we did that and got 4. Now we bring that back to here, because now we know that g of 2 is 4, and we're going to find g of 4. Well, that means I need to substitute 4 into this equation, square it, multiply by 3, and add 1. So I squared it, I multiplied by 3, and I added 1, and I got 49 for the answer. You can also do a function composed with itself, and that's what part C is. F composed with f of 1. It means substitute 1 into f, and then take that answer and substitute it into f again. Remember, the rule for f of x was multiply by 2, because it said f of x, way back over the top, equals 2x. So if I'm finding f of 1, I just multiply by 2. So f of 1 is 2. Now I find f of 2. Well, the rule for f says multiply by 2. So I take that 2, multiply by 2, and get 4 for my answer. Part D, G composed with G of 0. So we start off with G of 0. The rule for G was square it, multiply by 3, and add 1. So I did that. I bring that back to here. Now I apply the rule for G again, which is square it, multiply by 3, and add 1. So I squared it, I multiplied by 3, and I added 1, and I got 4 for the answer. And that completes problem number 13. So let's move on to number 15. This time we have this rule for f of x and this rule for g of x. And we're going to do the same 4 parts. So to do f of g of 4, I have to first find g of 4. That means let x be 4 in the rule for g. So 3 minus 1/2, square the 4. 1/2 times 16 is 8. And 3 minus 8 is -5. Now I bring that back to here because now I know that g of 4 is -5. So I'm substituting that in here. Now I apply the rule for f. The rule for f says square it, multiply by 8, subtract 3. So I'm going to square it, multiply by 8, and subtract 3. And so 200 minus 3 is 197. So that's my final answer for that part. Now I'm going to do g of f of 2. So the first thing I do is find f of 2. So 8 times 2 squared minus 3. So f of 2 is 29. So I bring that back to here. And now I'm going to find g of 29. So that is 3 minus 1/2 times 29 squared. And 29 squared is 841. And now I'm going to do 3 minus 1/2 of that. So you can just do that in your calculator. 3 minus 1/2 times 841. Then you're going to want to write that as an improper fraction. I didn't do that right. So I get negative 835 over 2 for that answer. Then for part C, it's f composed with f of 1. So I put 1 into the rule for f. Remember that you always have to square it first before you multiply. Bring that back to here and now find f of 5, which is 8 times 5 squared minus 3. And we get 197. Now I'm going to do g composed with g of 0. So g of 0, You're going to put 0 in the place of x in the rule for g. So 0 squared is 0. 0 times 1/2 is 0. So I have 3 minus 0, which is 3. So I come back to here to find g of 3, which is 3 minus 1/2 times 3 squared. I put the 3 right here in the place of the x in the rule for g. And do the math. So 3 minus 1/2 times 9. And again, you can do that on your calculator. You can do it on paper if you prefer. But you should get negative 3 over 2. If you want to do it on the calculator, you're going to do 3 minus 1 fraction 2 multiplied by 9 equals, I don't think you can see that, but you get negative 1.5, if you can see that printout. And you want to change that to an improper fraction. To do that, you hit the second button right here, and you hit the fraction key again and the equal sign, and that changes it to an improper fraction, so you get negative 3 over 2. So you can do it on paper, you can do it with a calculator. That's up to you. Alright, number 19 is the same kind of problem. We're going to do the same 4 things. It's just this time we have 2 different functions. So here's our rule for f, here's our rule for g. So we need to find, first we need to find g of 4. So that means put 4 right here in the place of x. And I get 1 over 25. So now I have to find f of 1 over 25. Well, f says just take the absolute value of it. So that's the absolute value of 1 over 25, which you know, just take the positive numbers, just 1 over 25. Alright, next we're going to find g of f of 2. So I start with f of 2, which would be the absolute value of 2, which is just 2. Then I find g of 2. Well, that is 1 over 2 squared plus 9, putting 2 right here into the place of the x. So that's 1 over 4 plus 9, which is 1 over 13. Okay. Now, part C. Find f composed with f of 1. So f of 1. So I find f of 1, which is the absolute value, so I just get 1. So now I have to find f of 1 again, which is still just the absolute value of 1. So I still just get 1 for my final answer on that one. Part D. G of 0. So I put 0 in the place of the x. You get 1 over 0 plus 9, which is 1/9. Now I find g of 1/9. Okay? So that's going to be 1 over 1/9 squared plus 9. I took the 1/9 and put it right here in the place of the x. Now, if you'd like to do this on the calculator, let me walk you through how to do that. You're going to enter 1/9, so 1 fraction 9, 9, not 2. 1 fraction 9, and then you're going to hit the x squared key, and then you're going to add 9 to it, and then you're going to change it to an improper fraction. So that second fraction equals, and you get 730 over 81. That's just doing the denominator part. Let's see if I can show you that. There it is. 730 over 81. So now what you want to do is 1 divided by that. So let's type in 1 divided by 730 fraction key 81 equals, you get okay, let me do that over because I missed typing the 3. I was trying to hold it in my hand. I missed typing the 3. Alright, let's do it again. 1 divided by 730 fraction key 81 equals, and you get 81 over 730, which is true because it just means take the reciprocal of it. But I wanted you to see how you could do that with the calculator if you needed to. Many of you can just do the math, but in case you need the calculator, I wanted you to see the keystroke to use. Alright, now we're going to number 23, which is a little bit different in that it asks us to find all the rules, not just for a specific number, but for x itself, and to talk about the domain. So this is going to be a good review for us about finding the domain of a function. So I pulled out the handout that I'd given you some time ago and said the domain is the set of all real numbers unless you have a radical or you have a denominator. Okay? So if there's no radical and there's no denominator, then the domain is all real numbers. Well, as I look at this one, for function f, I see no radical and no denominator, so the domain is all reals. Same thing for here. Okay? Now we're going to find the rules. Remember when I showed you those little boxes, I said when you can find the composite rule, you're finding the one rule that would replace these two working together. Well, that's what we're doing in this group of problems. So part A on number 23 was to find f of g. So that's f composed with g of x. So what I do is take g of x, whatever it was, which was 4x, and substitute it into the rule for f. Well, the rule for f says multiply by 2 and add 3. And I do that to this. So I multiplied by 2 and add 3. Wait a minute. I got my parentheses in the wrong place. I multiplied by 2 and then add 3. That should be only 2 times the 4x. So I get 8x plus 3. Now, when you talk about the domain, you start with the domain of the inside one. So that was all reals. And then you ask, is there any part of that that won't work in this? Well, this is still all reals because there's still no denominator, no radical. So the domain for this composite function is all reals. And when you do this on the homework, there's two choices. It says you can click here and use an inequality, or you can click here and choose all real. So for this problem, you'll click here and choose all real numbers. All right, part B. Now we're doing G composed with F. So I'm going to apply the rule of G to F. F was 2x plus 3. The rule for G says multiply by 4. So I'm going to take that 2x plus 3 and multiply by 4 and get 8x plus 12. Now let's talk about the domain again. We start this time with the domain of F, which is still all reals, and ask, is there any part of that that won't work here? The answer is no. So this domain is all reals again. Alright, F composed with F. Remember F was 2x plus 3. So I'm going to take that 2x plus 3 and put it in right here. So I'm going to have 2 times 2x plus 3 plus 3. So that's what I have written here. 2 times 2x plus 3 plus 3. That gave me 4x plus 6 plus the 3, which gave me 4x plus 9. Now I talk about the domain again. The domain for F was all reals. Is all of that okay here? Yes. So it's all reals. And I know it's okay because there's no denominator and there's no radical. That's the things that cause problems with domains. Denominators and radicals. So we'll look at that in a minute, but for right now it's all reals. Alright, the last part, part D, is G composed with G. G was 4x, so I take that 4x and put it right here. So I'm going to have 4 times 4x, which is 16x. The domain for G is all reals. That still works here. So this is all reals again. Okay, now we're going to number 27. We got two different functions again, but again, there's no denominators and no radicals. So the domain for F is all reals, and the domain for G is all reals. So I do part A, F composed with G. I take G and substitute it here, and the rule for F says square something. So I need to square x squared plus 4. Now to do that, I would recommend that you come off to the side and do x squared plus 4 times x squared plus 4 and multiply that out using the distributive property, combine like terms, and when you do, you'll get x to the 4th plus 8x squared plus 16. So to talk about the domain, I start with G, which was all reals. Does that still work here? Yes. So this domain is all reals. Part B, G composed with F. F, the rule was x squared. So I'm going to apply the rule to G to x squared. Well, the rule for G says take something, square it, and add 4. So my something is x squared. So I square it, and I add 4, and that gives me x to the 4th plus 4. The domain for F was all reals. That still works for this. Now I'm going to do F composed with F. Well, F was x squared, so that means I need to take something and square it, and my something is going to be x squared. So when I square x squared, I get to x to the fourth. The same routine, all reals, still works, domain is all reals. Part D. The rule for g of x was x squared plus 4. So I put x squared plus 4 back into g, which is square something and add 4. And by the same token, x squared plus 4 squared, just like we did right up here, becomes x to the fourth plus 8x squared plus 16. Then I add the 4, so my final answer is x to the fourth plus 8x squared plus 20. The domain for g was all reals. That still works here. All reals. Alright, now we move to number 29, and I see I have denominators. Well, the rules are that when you have a denominator, that denominator can't be 0. The reason being that you can't divide by 0. So if that can't be 0, you think, what would make that equal 0? If x were what? 1. If x was 1, the denominator would be 0. So this domain is that x cannot be 1. That's the does not equal sign. X does not equal 1. Alright, on G, what about this domain? Well, x, the denominator can't be 0, and it's just x. So for that domain, x can't be 0. Alright, so let's see what we got going on here. We're going to find f of g of x. Well, g is 2 over x. So I have to apply the rule of f to that. Well, the rule for f says take 3 and divide by something minus 1. And my something is 2 over x. Alright, now this one you can't do on the calculator because we got variables involved. So we got to really think about how to deal with fractions. I have to have a common denominator to combine these. So instead of 1, I write x over x. So I have 2 over x minus x over x. Now that they have the same denominator, I can write it as the single fraction 2 minus x over x. Well, now I have a complex fraction, a fraction on top of a fraction. Well, a number on top of a fraction. So I changed it to a division problem because that's really what that means. 3 divided by that. That was the denominator. Well, how do you divide fractions? You multiply by the reciprocal. Remember, keep, change, flip. Keep the first, change to multiplication, flip the second one. So I did that there. Now I multiplied straight across. I pretend that this is 3 over 1. And I multiply straight across, and this is my final answer for the rule for f composed with g. Well, now let's talk about the domain. We start with the domain for g. Well, that said x couldn't be 0, so I already know x can't be 0. Now I look at this to see if there are any additional restrictions. Well, I still have a denominator. Well, what would make that 0 if x were 2? So not only can x not be 0, x can't be 2. Now, when you put this in my math lab, it tells you to separate your answers with the comma. And if you leave that comma out, or if you type a period instead, it's going to count it wrong. So you've got to learn to be careful about the way you type that in, because it clearly says in the instructions there, separate your answers by a comma. So that's my domain. All real numbers except x can't be 0 and x can't be 2. And the part that's already written there in the My Math Lab looks like this. The set of x such that, and then you fill that in, and that's already there. So it's read the set of x such that, this line means such that, x is not 0, x is not 2. This is the part you have to type in. This part that I just wrote in green is already there on the computer. Alright, same problem, part B. So I've written down the domains again. Remember, everything except 1, everything except 0. Now I'm going to find g of f. Well, f was 3 over x minus 1, and g is 2 over that. So I have to put 2 over all of that mess. So I can separate it to a division problem. 2 divided by that is 2 multiplied by the reciprocal. I treat that as 2 over 1. So 2 times x and 2 times negative 1, and then 1 times 3. So this is my rule for g composed with f. Now, domain. You start with the domain of the inside function, which was f. And f was that x can't be 1. Then you look at your new rule and say, are there any additional restrictions? Well, there is a denominator, but the denominator does not have a variable. Therefore, there's no way for that denominator to be 0. So that's the only restriction that we need. So when the computer says the set of x such that, you're going to type in x does not equal 1. And by the way, the does not equal sign is on the bottom of the screen down there in your little toolbox, in one of the things that you can choose in that toolbox. Same two functions. This time we're doing f composed with f. So I'm doing f of f. Well, here's f. And what does f say? 3 divided by something minus 1. And this is my something. So 3 divided by something minus 1. Well, now my denominator is x minus 1. So I change this 1 to x minus 1 over x minus 1. Now that they have the same denominator, I can combine them. But watch this. It's 3 minus x minus a negative 1. That's how that became a plus 1, because it was minus a negative. That became plus. So I combined that 3 and 1 and got 4 minus x, and separated it into a division problem. 3 divided by this is 3 multiplied by the reciprocal. Just flip that fraction. Then I distributed the 3 times x and 3 times negative 1, and I kept the denominator. Let's talk about the domain. You start with the domain of f, which was x does not equal 1. You look at the new rule and say, is there anything else I have to leave out? Well, you can see here that x can't be 4, because if it is, that denominator is 0. So you put a comma, x does not equal 4. So you have 2 parts there for that domain. And finally, we're on part D. which is G composed with G. Remember the domain was G, was X does not equal 0. G is 2 over X. So when you do G composed with G, you put 2 over X right here. So you have 2 over X, which is 2 divided by that, which is 2 multiplied by the reciprocal, which becomes 2x over 2. Those 2's will cancel out, and you get just x. Well, way back up here in the domain, I had already omitted 0, and I look at this. Well, there's no radical, there's no denominator, so there's no additional restrictions. That's my domain. And that's the end of this lesson.